All right, so that's what this part does here. This transistor up here runs this yellow LED. It's what switches power on and off to this LED and to this pin number 5 here. And then this transistor here runs the green LED. It switches power on and off to this green LED, which is on pin 6 here. Excuse me. And then you have a chip here. This chip is a hex NAND gate. So there's 6 NAND gates in here. Let's see now. This chip here, if I remember right, it is a I'm trying to think now. I don't remember. This one is a hex NAND gate. Okay. This little piggyback board here, this is where your input from the keypad that arms and disarms, that arm and disarm is done through this little piggyback board. And this chip is got hex inverter. Well, Schmitt triggers are hex inverters on there. 6 of them, I believe. It's a hex Schmitt trigger inverter, and I believe it's only using 3 of the 6. And I believe what it does is one, it gives a debounce for the switch. When you close this switch, they tend to bounce, and this debounces that switch. Okay. And also does an inverting for this. This is a Type D flip-flop, so there's 2 Type D flip-flops in this chip, and it's only using 1. Okay, and then that output from here drives some of these NAND gates in here and here, and does various things. Let's see, what else? These are some things that I kind of figured out I reverse engineered the board and made a schematic of it the best I could, trying to figure out what this pin 9 is. But yeah, so if somebody's got a set of instructions on this, I'd sure like to get a copy. And this here, oh, I remember what this chip is. This chip is a it's got 4 voltage comparators in it, and it uses 2 of the 4. And what that voltage comparator does is tied in with this alarm loop, okay? And when they stack 2 of those voltage comparators together, it's called a window comparator. So it's looking for a voltage limit upwards and a voltage limit downwards. So there's a range in between that the board will not go into alarm. If that voltage goes higher than its high limit or lower than its low limit, okay, it sends the board into alarm. Okay, and that has to do with this resistor and so forth on there. So if somebody's trying to overcome the circuit, say they get access to the wire in between the resistor at the end and the board here, okay, and they try clipping another resistor on here, well, that resistant value is going to change the voltage on this circuit, okay, and there's an acceptable with that window comparator set up from this IC. It's going to there's a, like it says, a window comparator. There's a window of voltages that's acceptable, okay, where it won't go into alarm. And then anything lower than that, so if they try shorting something and it goes lower, or they use a different, try to tie in a different resistor or something, try to overcome this and it goes higher. But that's what the window comparator on there. I'm not an engineer. It's just what I've looked all these parts up on the internet and did some reading and watched some videos, and just kind of putting two and two together, that's basically what I think is happening on this board. But I'm still stumped on this pin 9, because when you first turn the board on, put power to the board, this comes on, as does the siren. Okay, and this circuit does not time out. Does not time out. It stays in that state until somebody comes along and resets the alarm with the keypad on these two pins here, these two terminals. And that just doesn't seem right. You know, if you're away, say you're on vacation or something, you're gone for 2 weeks, and after a couple days you're gone, something happens, the power goes off, the battery drains, and the power comes back on, okay, from the utility. This thing's going to go into alarm, and it's going to ring 24/7 until somebody can reset this. This doesn't seem right. Something doesn't seem right there. So that's why, if I had some instructions, there may be something wrong on this board that I don't know about. But other than that, it seems to work fine. When you turn the power on, these lights come on, it's in alarm, you reset it, the blue LED goes off, the white LED goes off. You can now close the door and set your alarm loop. You can arm it with your keypad. These two will be on, the power will be on, and the board is armed. If you open the door, this light goes off, this LED goes off, and this blue one comes on because now it's now in alarm, and I can reset it. Okay, I can turn the alarm off with the keypad from these two pins here, and this light will go off, this LED goes off, and I can reset it. I can close the door, the green LED comes back on, I can rearm it. Okay, the yellow comes back on, the red is on, and it's back in the alarm state. And I can trip the alarm and then reset it, and everything's fine. It's just, if power is dropped from this board and then reestablished, this LED indicator comes on, as well as my white indicator from pin 9, which is not hooked up to anything, and stays in alarm. And so, if I had some instructions, if somebody out there in YouTube world has the instructions on a MicroState 630, I'd appreciate knowing about it. Thanks, guys.